Hello, everyone. Good morning. Thank you all for joining us today. I'm Alan, and it's my pleasure to welcome you to our virtual event. We have an exciting and informative session here for you. Our focus is on building and owning your AI stack, tackling AI challenges, experiencing a live demo of deploying Llama 3 on GMI Cloud. We are honored to have three speakers today. Alex Yeh, CEO of GMI Cloud, Jordan Nanos, machine learning architect of Hewlett Packard, Yujing Qian, software engineer manager of GMI Cloud. Before we dive in, just a couple of reminders. Please feel free to use the Q&A function to share your thoughts and questions throughout the presentation. Just click the activity button in the bottom right corner to access the Q&A feature. We will have a dedicated Q&A session at the end. We will randomly select some questions to ask the speakers. This session is being recorded and will be available for replay on our LinkedIn and YouTube channel. Now, I'd like to hand it over to Alex Yeh, our first speaker.
So I'll give you a little bit brief introduction about who we are. Now we're a relatively new company in the Valley. GMI stands for General Machine Intelligence. So we're here for a long haul, building an AGI future, and being I call it the AI TSMC, being the infrastructure that supports along the entire stack of building AI applications on our cloud. So we're NVIDIA NCP. Our company has roots stemming from 35 years of ODM experience from Taiwan. We're backed by Headline, and we're about to announce our Series A very, very soon. And our entire core team came from Google and Google X specifically. And they're supporting us to build the entire cloud platform. And we have operations as well as data centers across in APAC. We have 3 that's already up and running. We have 2 more that's coming online in mid-August. Next slide, please. We work with industry partners, and we're very, very channel friendly. We work with our customers from Europe, Asia, as well as US onshore. Customers coming from kind of Series C to Series B. We also have a couple public companies that are using us, from gaming companies to advertisement companies like Ubisoft, as well as I would say headhunting software company are also using us, undisclosed at this moment. Next slide, please. So what is GMI, right? And what do we build? So our vision is to empower anyone to build AI application with one click, right? Similar logic to how Shopify enables anyone to build an e-commerce platform, right? If you're an influencer, or well, in that analogy, or if you're a founder, you want to build AI applications, we want to empower you with not just the raw compute itself, but also all the available tool sets you need to build the applications you want. So you're able to use our platform similar to building Lego blocks. Instead of going to Hugging Face, downloading the right driver and libraries, we have all available resources on our platform for you to use. It's already downloaded on a local cache to support on both training or inferencing or fine-tuning on our platform with just one click. Next slide. So what our platform built around is really for the inferencing future. We recognize and see how powerful 4.0 is, and then we want to build, instead of having a bunch of kind of clusters in middle of nowhere in America and Texas or Arkansas, for example, we want to have it in located close to population dense area. That's why we chose kind of Asia Pac, in Taiwan, in Malaysia, and in Thailand to support the kind of Asia ecosystem first. And we're building back our data centers and right now we already have 3 or 4 data centers up and running. We aim to have 30 by the end of next year. And so instance accessibilities, we allow anyone to access to our GPUs via containers. And you can also, if you're a larger enterprise, you can also give that containers similar to kind of Google Admin, where you can assign different containers to different departments, and you have firewalls in between, so you won't see each other's researchers' usage. So it's also great for academics usage. You don't want other peers to look at kind of what you're training or fine-tuning on. And so kind of on the ease of use, right? Instead of compiling and also using YAML file to pull resources, you can use container. It's a very easy drag and drop button on how much RAM, how much CPU, how much GPU that you need. And of course, we will follow up with a demo session with our engineering team later, right? And performance, right now, we only have one SKU, which is the SXM H100s. It's all connected by the state-of-art IB from NVIDIA. And so you will be able to do either bursts or large-scale training on a non-blocking with our H100s fleets. Next slide, please. So right now we have 3 sites that's up and running. We have Malaysia and Texas coming soon. Texas will be ready by end of summer. We are using only tier 3 and tier 4 data centers. That's at least 99.9% uptime. And we'll have over 3,500 H100s available for people to use. And also in the future, we'll offer optimization tool sets on 2 fronts, right? One on cost, another is on efficiency, right? For example, if you're running on training workloads, you want a larger cluster, and we'll auto route you to a certain area, right? And also because of the power costs and the different and tax situation in different countries, we'll auto route you on the lowest cost possible locations, right? If you're inferencing, you don't need IB, then we'll route you to different locations. Depends on how you want to optimize it, right? It's on speed, on cost, or the large productivity curve on the right, right? Then we can also do that too. Next slide, please. So if you think about us, we're in one sentence, right? We're kind of a Together AI plus Lambda, where we want to control the hardware, right? And so that we can give our customers the highest availability and also accessibility and reliability. I think that's what's most important. Right now, there's a bunch of, I guess, CSP out there using other people's GPUs, right? So it's hard to QC how to maintain the uptime. But if you choose to use us on our platform, you will also always be guaranteed on reliability, because we own these hardwares, we control these hardware, right? You will be always assessed. Well, our tech support team will always be able to support you on what you the problems you faced, right? So from the bottom kind of GPU stack, we built virtualizations and IBs, which we will mostly suitable for smaller founders, smaller customers, as well as smaller enterprises, that allows you to start building instead of figuring out how to pull in the infrastructure. We also have control plane that allows people to better monitor their workloads on data pipeline visualization tool sets, etc. Right? And on the right, the model delivery network, which is amazing and interesting. You guys probably see the problems on, say, RabbitOS or Humane Pin, right? They built a pretty nice hardware, but I think the problem was the infrastructure, right? The GPU infrastructure. It was really slow, like 5 seconds to get an answer, right? It's because there's not enough GPU scattered around where the query is happened, right? Just back and forth from, say, middle of nowhere, say in Arizona back to San Jose, that's at least 300 milliseconds of delay, right? And depends on the SKUs that they're using on the GPUs. It might be the compute delays even further, right? So our goal is to have the broadest serving decentralized GPUs across the board, across America, across Asia, so that when you want to reach your users, we will be able to do that for you, right? And services on applications, we already provide various publicly available models, right? So you can start training or fine-tuning or inferencing immediately. Next slide. Yep. And right now we offer SSH access to if you want to build your applications. In the future, we'll also offer API services so that you can even build your applications on your platform easier. Right. So right now we have a couple of images that's pre-built. In the future, we'll offer a lot more, just these models, so you can kind of drag and drop. There's a couple interesting pilots that we have done, right? There is a streaming company, one of the largest streaming company, came to us and say, hey, we want to build a voice-to-voice model, right? Where we want to have our streamers to talk in a different language instantly. And so we basically use all the open source models and pre-build three things, right? Kind of the voice-to-text, text-to-text, and text-to-voice, and back, right? So we have all of that on our platform already. So like I said, right, you can just use basically Lego blocks idea and build it on our platform, right? And you can offer that to your customers immediately. So we can have hosted SSH and hosted API services in the future. Next slide. Yeah, so right now, we're building a full stack platform from private cloud. If you want to reserve for a long duration of training times, or if you have expectant kind of customer workloads on inferencing, then obviously we will start at $2.20. And we also have on-demand that allows a burst for people for use kind of a single card for 14 days. And as we are ramping up more cards, that will be offered to our customers more. Next. All right. Thank you, everyone.
All right. Thank you, Alex, for the impressive presentation. In the next session is a 20-minute fireside chat with a special guest, Jordan Nanos, a machine learning architect at Hewlett Packard. I will be asking them some questions on behalf of the audience, and I'm excited to hear their insights. So feel free to jump in. Hello, Jordan.
Yeah, hi, everyone. Very nice to speak to you today.
Hi. For the first question, I would love to, this one is for Alex. What are the primary challenges you see the companies facing when it comes to owning and managing their AI stacks, particularly regarding scalability and efficiency?
Yeah. What people don't realize is it's remarkably hard to manage hardware. It's incredibly expensive. That's why people tend to choose on renting, which is, we're trying to solve that part, right? We're trying to do all the heavy lifting. It requires massive amount of logistics, moving servers everywhere, and so you can always basically we're trying to simplify a lot of steps for people, and so and I like to quote what Jeff Bezos was saying, quoting about how he described AWS is it requires a lot of operation excellence, right? So these uptime, right? It's not done magically by software, but when there's error, we'll have engineers coming in on basically checking the logs, on solving issues, right? And then slowly tuning that to over 99.9% plus, right? So that is the step that's required. Sometimes the loose wire, loose IB, all kinds of could have problems, right? Have issues, or even earthquakes in Taiwan could knock off IBs, knock off the GPUs, right? So where I'm getting at is, we're trying to be the infrastructure stack and help lift all the situations and give you a easy to deploy containers. for people to deploy their AI. So your problem should only be focusing on, okay, there's something wrong with my data, instead of like, oh, is it something wrong with my IB? Is it something wrong with my GPUs? Right. So we kind of solve that infrastructure piece for you. Yeah, but it's difficult. And scalability, right? So we will have two things, right? So initially, we want to establish a standard SOP. We want to ensure the quality of service to our customers. That's why we insisted on using our own gears initially, right? And once we establish that, think about Uber, right? Once we have that, the kind of the fleets that we own and control, we establish a SOP and quality for our customers. Then we can expand out to other fleets that other people own, right? For example, there are a bunch of mining CSPs, that's mining companies that turn into a CSP, right? Recently, they don't have the right software or infrastructure. Then we're happy to give that support, right? And we'll send our team there in their data centers and our DevOps team to support them, to ensure that our customer will have the highest quality services. Someone asked, I think it's on AWS or Azure, right? AWS and Azure, they're not really AI optimized. They don't have the inferencing acceleration piece. We already have a VLM included in our services that allows, I think, 20x faster, right? And we can also offer hosted API services, etc., right? And also pulling GPU resources. We virtualize everything, including IB, which I know is something that not many players in the world have done. Kudos to our amazing engineering team from Google that built this function and feature. We really learn from kind of the not mistakes. We learn from the kind of shortcomings of the Google GCP offerings, right? And then we built a model really for engineers and for developers on how things should be done. And that's actually why they joined GMI in the first place. Like, oh man, I can't get any GPU resources even at Google X. Technically, they're the son of Google, and they can't get GPU resources, and the Vertex AI is kind of hard to use. So, that's why they joined us to build a platform really for engineers to scale.
Thank you, Alex, for the detailed explanation. And we will save the Q&A session at the end. So please feel free to leave your questions, and I believe all of them will answer your questions in the end. So the second question, I believe, is for Jordan. So from your perspective at HPE, what are the key security concerns that organizations need to address when building and owning their own AI stacks?
Yeah, absolutely. I think in this case, there's basically 3 layers at which organizations can have concerns related to security. The first is related to data. The second is the models themselves. And then the third is the applications. If we go top down, applications are powered by models. Models are powered by data, right? When you think about data, it's all about the privacy of the data sets that are being used to both train the models that are actually being deployed in the case of fine-tuned models, as well as the data set that is being accessed by a model in the event that you're using a retrieval augmented generation workflow, or you're using function calling or something else where the model depends on an external data set. Ensuring that data is private and there's no unauthorized access is important. The second piece is the models themselves. In many cases, models are served as endpoints. And so having the ability to authenticate users against the endpoint of the API is important, as well as being able to log all of the different requests and responses that are being submitted to the model and replied back with, so that you can monitor what exactly users are doing with the model endpoint. In the event, especially where there's multiple applications being built on top of one model endpoint. And that leads me to the third piece, which is applications themselves. This is really the layer at which compliance is a concern to certain regulatory requirements and where action is being taken. I've seen a lot of organizations start with internal facing model use cases like a software development assistant or a chatbot for somebody who works on a customer support hotline, or a blog post writing assistant or something like that, where if there's an issue with the model's performance, it spits out a bad answer, bad response. You have, in the worst case, a confused developer or a confused marketing blog writer. This is different than if you build an AI application into a public-facing part of your business, where any consumer can come along and chat with a chatbot on the website and potentially open up a security concerns or at least reputational issues. So in summary, yeah, there's three layers at which we see security concerns: the data that's being fed into the models themselves, and then compliance of the actual applications that are powered by these models.
That's quite insightful. Yeah, I believe, for a lot of audience will definitely care about their security about their data. So I believe that's kind of the question they would want to ask. And yeah, of course, we'll have a couple more. So the next one, I believe is both. How can the personalized AI stacks accelerate innovation within companies? And what specific benefits have you observed in your respective fields? Yeah, who want to answer first?
I think okay, so I'm gonna put on my my VC hat on this, right?
Yes.
So on the AI innovations, I think whenever there's a fundamental UI UX change on how interact with something, then there will be a revolution, right? Starting with the PC revolution, right? How you get information is completely different, right? And then to mobile revolution, right? Uber app doesn't work on a PC, right? Whenever there's a new interface change, there will be a revolution that will be coming, right? But we don't know the when and the how that format is going to be taken, right? So what I know is like we're in the information age, right? Which there's a lot of information on Google on search, and how do you sort these data? You have to crawl through blogs, crawl through information, websites, find the usable information. And what these transformer models are able to do is giving you the exact answer, right? That's actually what when Google started, it was like that. It's like, hey, search or feeling lucky, right? But feeling like wasn't great because the infrastructure wasn't there back then. And now we're going back. Now it's giving you the exact answer. So to answer your question, I think in short to medium and long term changes. On the short term, I think here's I hate to use prediction, but here's my thoughts that the media entertainment space, advertisement space will be disrupted, will be helpful. I think will be more attractive to people, right? Right now, all the advertisement images are presets, pre-built for everyone. You have some designers on a back end that designed it maybe on a 2 weeks or one month sprints and get the image done, and it will be for everyone to view. But that is not tailored, right? So with Gen AI, I think using kind of stable diffusion and such, you can have a pretty tailored approach on e-commerce, right? So that's like one application that would disrupt. Like all the images that you see, maybe on Instagram or Xiaohongshu, whatnot, will be tailored to exactly what you want to see, well, on website as well, right? So e-commerce, and advertisement. Streaming, I mentioned there's already a streaming company that's working with us to do kind of voice-to-voice model. And that application can also be used in call center. To how many times you call center, it's hard to understand the accent. Right, so this can easily be solved with this piece of technology. Gaming as well, you can create a lot of different in-game assets with Stable Diffusion instead of having someone to render the image and create the image for you. So that's also incredibly helpful. Medium to long term, right? Medium, I think, is like 5 years, 5 years, maybe even sooner, right? It's like enterprise RAG from what Jordan was saying, right? It's like AI agents that supports you, right? Just to give you an example, right? If you buy like a HVAC or like a fridge, how many times have you read the actual pamphlet, right? It's like when things break, like, do you actually keep that around? If you want, if things break, you would want to interact with some customer support and say, hey, how do I fix it, right? But there's not enough human resources to support every of these like bug problems. And so all you have to do is really just upload that pamphlet into like an AI agent and train it. That's it, right? And so it will have all the knowledge about this piece of equipment. We can ask that directly. So I think that's helpful. So I think a lot of these companies will start adopting that a bunch of different AI agents for various purposes, right? Fine-tuned model. So I think that's will come to life. But enterprise is typically slower, like 2 to 3 years. If tech forward enterprise is slower, and enterprise RAG, right? So everyone's kind of talking about that already. But sorting these data within the company, and that will boost productivity, right? I think that would be also incredibly helpful. And long term, how I'm hoping is actually on the biotech, mathematics, on material science side, where and drugs takes incredibly long time to develop, right? But if we're able to narrow down on the variables that can increase the probability of success on finding the right enzyme, finding the right protein, right? And we can accelerate the development process a lot more, right? We will see a lot more innovative drugs that can support a lot of issues, right? On genetics as well, on agriculture, right? This AI drug discovery is just one facet of what can be done, right? So similar to kind of material science innovations, right now, all the bottlenecks that we see in the world is material science issues, right? Faster chips, that's material science issues. Going to space, that's material science issue that can withstand heat, withstand pressure, withstand temperature, ultra low temperature, right? Bring to deep sea kind of explorations, right? It's also in materials issues. So I'm incredibly hopeful that it can not just summarize what we already know, but kind of innovate on and support on new materials, right? And biomaterials include like drugs or agriculture, genetics, exploring new kind of enzymes to support, basic humankind innovation. I think this will allow us to move to a next, I would say, level of civilization. I don't know what that is, like L1 to L2 civilization, whatever that is. So I think that's incredibly exciting to see in the future. I would say that was like a 10-year plus goal.
Yeah, of course. It sounds like you feel like AI is trying to take over the whole world and trying to change everything. But yeah, let's see how it goes. And what about Jordan? What do you think about that? And maybe Alex, seeing the world in a entrepreneur way, and as an engineer, how do you feel about that?
Yeah, yeah. Alex definitely has a view of the medium and long term that it makes sense, but I don't think about as much. So in near term, I think there's two primary applications I've seen developed. One is related to user productivity, and the other is related to kind of new creative output. And the biggest thing that always keeps coming up is whether an organization is choosing to buy that application that they're going to use to improve productivity or start generating new content, or whether they're going to build it for themselves. And it seems everybody's considering an AI strategy, but not everybody is considering building custom AI applications. So in the event of enterprise RAG, this could effectively be a feature that is going to be turned on in your OneDrive or your SharePoint service from Microsoft. right? And is that sufficient for an organization to have an AI strategy, which is, let's teach everybody to use this new feature that's been turned on for us, as opposed to, let's go and build, in our case, chat HPE, where we have quick specs related to all of the hardware we sell. Let's go build a custom application that's got a lot of detail about our hardware specifications, and then let people chat with that documentation. In our case, we've chosen to go, as an organization, we've chosen to go the route of building custom applications. And the reason why is because we want to have agility and to have control over costs. In the case where you depend on somebody else's software development lifecycle for your innovation agenda, it can mean you're moving a little bit slowly, and you aren't able to address certain custom things that you want to do in the future. And then in other cases, there's a chance for costs to really explode. As new features get rolled out, you don't really have control over what hardware you're running on or what user-based licensing you have to pay. And as you build a dependency on others' applications to do your business, suddenly you need to pay them more money over time in certain cases. So all of this leads me to suggest to organizations that AI is very similar to the internet in that at the beginning, there was probably a lot of organizations who were outsourcing the development of a website, asking people to help them have a presence online. And that's probably the way we're dealing with AI as well. Many organizations are learning about AI from vendors and not developing it custom themselves. And I just think that it's going to become more and more important over time to develop custom AI-powered applications and bring that in as a competency within your organization. So to do that, you need a partner that's going to power whatever custom or whatever fully controlled application you're going to be developing. And that's where services from GMI Cloud, I think, come in very nicely. Like for those who are building custom applications, this is the engine to make that, that innovation go.
Totally. It's only actually we get a couple more questions left, but because of the time issue, I decided to go for the last questions. And this one is for Jordan, maybe. Alex, feel free to jump in if you want to answer that questions. For the last one, how is the open source community contributing to the advancement of the AI development? And what roles does the AI ecosystem play in fostering innovation and collaboration?
Yeah, the open source ecosystem is huge. It's vibrant in this space. I mean, you've heard Alex refer to Llama 3, to Mixtral, to VLLM. These are all open source technologies that are powering the sort of experience everybody's looking for, which is a controlled LLM-powered application.
Yeah.
Obviously, we at HPE would also not be able to build many of our products without contributions from the open source community, even at the hardware level, in terms of specifications, things like that. I think the biggest thing this speaks to is just the fact that this pace is not going to slow down. It seems like more and more people are contributing to the AI open source ecosystem over time. It's not like it's falling off a cliff and getting slower. It seems like my favorite saying I heard from a friend who works in research, who said that he's afraid to go to sleep because when he wakes up, there's going to be 5 new models he's got to read and papers he's got to read. And the more he goes to sleep, the more he has to learn, the more he falls behind, right?
Cool. Maybe 500.
Yeah. But I think the big thing to point out there is the fact that, and this is my favorite saying about open source, which is that open source is free if you have the time, right? If you have the time to dedicate learning all about all of these new things and build them together for a service that works for your business, then yes, open source is free. But fundamentally, most organizations that I work with need a partner. They need a partner that has expertise in certain areas across the open source ecosystem. In many cases, they need many partners, and they need to simplify that whole landscape, like the whole surface area of different open source tools. What is going to be the best thing for my business and specifically this first project I'm working on, right?
Yeah, that's very insightful. Just a quick question, just for my side, because you just mentioned that there are millions of open source papers, essays you have to read, study, and how could you choose the most perfect one for your company, or maybe for your application, or maybe for your work?
Yeah, I think it's just time. Like over time, the market kind of consolidates on one or two technologies, and then at that point, it doesn't really matter which one you pick. If you go with Ubuntu versus Rocky Linux, I don't think it matters. But a while ago, there was dozens and dozens of viable Linux distributions. Now it's really just everything's based on Debian or Fedora. So anyway, that's one way of thinking about things. I could say the same thing about PyTorch, right? It seems like everybody is building models with PyTorch, whereas when I was first learning about machine learning, it was all about MXNet and Caffe 1 and Caffe 2, and then TensorFlow was more popular, and now we've got JAX. It's really not as big of an ecosystem if you just give it time. The most important thing is that you need to have agility to change over time, which is to say, if suddenly JAX becomes the runtime for everything, and all of the latest models that are being released depend on the JAX runtime, which is not, I don't think, going to be the case, but you have built, if in that scenario you've built an entire stack that's all dependent on PyTorch, well, that's a problem. So 5 years ago, even 10 years ago, you pick a different library than PyTorch and you have problems today. If instead you retain optionality, you practice that agility, you partner with people who have experience across the ecosystem, then you can have the agility to change. So I think when things are new, it's important to not build dependencies on the new stuff, but at some point when the market consolidates around a certain open source technology, you have to be willing to commit to something, and only time and experience kind of gives you that perspective to pick what's going to be the winner.
Totally. All right, I guess we're running out of time. So thank you, Alex and Jordan, for your time and for our chat. So I guess that's it for this session. And coming up next, it's Yujing. We have Yujing demonstrating how to deploy Llama 3 on the GMI Cloud, which is incredibly convenient for data scientists. So if you guys are interested in it, just stay until the end. Welcome, Yujing.
Thanks, Alan. Hi, everyone. My name is Yujing. Here, I will be presenting some of our cool platform and focusing on one of our topic today, which is how we can develop your personalized AI stack using Llama 3. Llama 3 has been debuted about over a month now. It causes a lot of turmoil to the existing open source community as everyone's rushing towards it, try to fine tune it, try to test it out. And today we're going to showcase how we can leveraging our GMI Cloud platform to quickly get you started on Llama 3. Without saying, I will present my tab. All right, so this is what we're looking at is our is actually our production platform. On the left side panel, you have on the very top, you have the GMI icon, of course. And once you have reserved a certain resource, you will have a similar interface as I do here. So you can view all your resources, managing all your containers that's running, managing your SSH key that you use to log into different containers. And I would say one of the most important thing is you can create your own container templates. You can pull it from Docker Hub, you can pull it from GCP, whatever sources you want. So you can always have your own container ready to run on our H100 GPUs. Now let's go to the container itself. As Alex has introduced previously, one of the key features of GMI Cloud is providing a customized container for you to bootstrap your work quickly. We also provide a bunch of different preset images you can use, for example, for Llama inferencing, for fine-tuning the models. So you will think this is kind of similar to, for example, GCP has provided thing called Workbench, Vertex Workbench, except GMI's container solution is more flexible because we allow any container you build by yourself, and we allow customized packages into pre-built containers as well. So it's really flexible. Now, when we talk about Llama, usually people will just think about fine-tuning and inferencing. So this is the two containers I'll be showcasing today. First, when you come to the container page, you can pick to launch a container. And then you'll be directed to choose a container based on one of your pre-existing templates. For example, here we can pick using VLM inference, which is a pre-configured environment for VLM inferencing. We also support other inferencing frameworks, for example, TensorRT or pre-built NVIDIA Triton server. So once you have fine-tuned your own model, or you just use the checkpoints, you can use this kind of technique to make your inference more efficient. After picking the container library, you can pick what kind of resource you want to do. I think correct me if I'm wrong, Alan. So for this time, we'll be offering 1 card or 2 cards options. So most likely you'll be able to pick between 1 cards or 2 cards, and you can specify, for example, how many storage and how many CPUs you want to use, as long as you have the resource reserved. Then when it comes to port mapping, usually we have the standard port 22 and AAA exported, 1 for the SSH, 1 for the Jupyter Lab access. You can also have your own port forwarding map stated over here. Again, we're focusing on flexibility. So if you want to build a application for a corporation or for your personal use, you can specify a port forwarding here. We also support the option of mounting local storage and also NFS. Here, I'll be using an NFS called Model Garden, which is default NFS, which contains several pre-downloaded models, so I don't have to let everyone wait here for another hour before the model is loaded. Of course, you have to have your public key ready in order to SSH into the containers you build. So you can follow the step here to add your SSH key. Here, I already have one added on my laptop. And in the end, just give it a name. That's, for example, and press launch. Make sure you have enough resource before you launch the container. And usually, depending on the size of the image, it could take up to a couple minutes. We're not going to wait for a couple minutes here. See, this one is starting right now. So I'll just be using the 2 containers I have already prepared. Let's start with the fine-tuning run. As you can see, we provide SSH access directly, or you can go using the Jupyter Notebook. Here, I will just go with the Jupyter Notebook. Right. So from this point, it's actually pretty similar to, for example, GCP Workbench. We have a suite of different containers already registered on our platform, so feel free to use when you have the access. So this is a standard fine-tuning script we have here using the Hugging Face transformer library. We also support deep speed here, and you can also configure your own deep speed config. And in the end, you can just save the model to a predefined location. Due to the time constraint, I'm not going to let it run for the hour. Instead, I will jump directly to the inferencing part, which costs less time. So once you have done the fine-tuning, for example, you can save the model to an NFS location. Then you can create another container to do your production inferencing job. For example, here I'm going to use this dual card inference demo. Again, when we talk about Llama model, please go to Meta's official form of distribution and agree to their term of agreement. Because we're showcasing our H100, so I'm going to use the 70B model today, which is the larger one. And let it run. See how GMI's GPU works.
Finger crossed.
Finger crossed. While we're waiting for the model to load, just saying, if you go to the terminal, you should be able to see your resource as well. For example, if you type NVIDIA SMI, it will tell you, for example, this container has 2 GPU attached to it. Yeah. And this is actually where the flexibility lies. So you can install any custom package you want, any framework into the Jupyter Notebook using this terminal. You can do monitoring on your resources and managing all your, for example, incoming traffic. We also support a couple external IP, so you can even use them as a production service if you, for example, want to use 2 GPUs to serve your own model to the general public. All right, looks like the model capturing has finished. So here we'll just have a nice little radio UI, as I think most of you have been very familiar with if you are in the LLM domain. So let's ask a question. Tell me a joke about GPU. What would it say? Why did the GPU go therapy? Because it was feeling a little laggy and needed to boost its self-esteem. Not too bad for the Llama 3 70B. All right.
Whereas you can play it for a whole day, right?
Yeah, you can play it for a whole day. Yeah. While you're waiting for example, the fine-tuning job to complete, you can have another instance, just chat with the model to pass time. Yeah, but this is.
I think it's very important to have a Scarlett Johansson's voice in it.
That's right. Maybe our next pre-built container will solve the job. Also, as Alex has mentioned, we support the speech-to-speech translation imagery. It will be released on the platform as well if you have access to it. With that said, that basically concludes how we can build our personalized Llama 3 using GMI platform. I will hand it over back to Alan.
Thank you, Eugene, for the perfect demo. For the last part, perfect. We have around like 9 minutes for the Q&A session. And I just saw some interesting questions. For the first one, maybe Alex can jump in and just answer this question. How do you compare your offering with the competition, like with the Octo AI endpoints and N-scale endpoints for over GPU at per hour with the AI services on top?
Yeah, I think the most important thing is having and controlling the nodes, right? I'm not sure how Octo has built their stack, or whether they rent GPUs from other players, from AWS, etc., or from Applied Digital, whatnot. But we're an end-to-end platform where we control our nodes. And most important thing is, if you want to run a actual application in the future that's reaching to millions of users, we will be able to support that, right, and at an affordable cost, because we actually control our fleets. And so in terms of reliability, it will be better than I would say our competitors. Whereas we faced kind of multiple this issues that there's a software sitting on top of us. Sometimes it's not even kind of our infrastructure, but it's kind of they're dealing something on the software on top, right? So it's just like configuration issues. So I think sitting on, here's what I believe, right? whether you're developers or larger enterprise, you want to sit on one platform only, instead of going to multiple vendors, finding compute resource, virtualize it, finding API services, etc. So you want to sit on one platform. I think that's the difference, right? And we have the broadest serving GPU fleets across in Asia at this moment. And so if you want to reach your customer with low latency in that area, then we will be superior in that aspect. And of course, we're continuing to expand. And we built 3 data centers in, I would say, 6 months, actually, 3 months. And we're incredibly fast in deployments and operations. And so, our goal is, again, right, to expand to 30 locations by end of next year across US, Europe, and Asia, right? So we'll be able to reach your customer and support your applications and support your go-to-market with no delays.
Yeah, I hope that answers your questions. For the next 2 questions, I believe it's for Eugene, right? So, are developers able to collaborate effectively on the platform? Hello, Eugene.
Yes, there are actually multiple ways. So the way we design this is we imagine a multiple data science working scenario, which we believe is one of the most common use cases for corporate or personal uses. One of the things they can collaborate is, for example, this is a very easy to use notebook instance. You can pass the notebook token to everyone else. So everyone with the token will have the access to the same notebook. That's one way we can think about a collaboration. And again, you can use the shared NFS storage. So for example, one of you passed in a model checkpoint, or one of you downloaded some data sets that can be shared across the same organization.
Interesting. And I believe the last question is also for you. How do you ensure the protection of my data and privacy? In other words, what security measures do you have in place? Important.
Right. So on data security side, all the storage are dedicated to you. That's first. And also we are using, for example, NVIDIA Bluefield, if you think about it, to further improve our data security. So as long as you don't share your instance with people you don't trust, there shouldn't be too much of a problem at this point.
Good. So it's not a big issue for the data privacy, right?
No.
Okay. I believe that's all of the questions. Well, that's all for now. And thank you all for joining us today. We appreciate your time and participation. The recorded video will be available on our LinkedIn and YouTube channels shortly. Please follow our LinkedIn page to stay updated on the latest information about the AI industry. Have a great day. Thank you for your time.